Hello, good morning.
Good morning.
Good morning. Give me a few minutes. Let me start.
Ma'am, you are not audible. You are on mute.
So before going to the today's session, let's do a quick Q&A from the last class. Okay. So can someone unmute and tell me what is Cilium? Why
It's
we need?
container networking interface.
Okay. Why is it needed in Kubernetes?
For the networking, like with the help of this, the pods can get the IP and
Okay. So mainly for IP address management. And this is CNIs are used for networking in Kubernetes. So Kubernetes does not have inbuilt networking solution by default. So we have to bring in some additional tools to provide networking. So that's why we are using Cilium or Calico or other CNI tools. Okay. And what is the main feature of Cilium? Why is it so popular compared to other CNIs?
Better observability at free of cost and faster than Calico.
Yes. Because why Calico is not getting so familiar, especially the Cilium is using eBPF technology, and which provides high performance networking, and it has security because all the executions are done at a sandbox level in the kernel. So the security is more. So during the attacks, it cannot be compromised so easily. And another advantage is it provides better observability. So Cilium inbuilt, which it has Hubble UI, which provides observability at the networking layer. No other tools by default they provided. Okay. Yeah. So which what is the policy that okay? So IP table uses IP addresses, right, for routing the traffic to the pods. But what does Cilium use?
IPADS.
Cilium uses, so we can configure different types of routing algorithms, but all are based on identity based assignments. So every deployment will have an identity number that we have seen it in the Cilium UI. Maybe I will show it now. But it has identity for each and every deployment has an identity. So you don't need to worry about pod IPs. So that's how it does the traffic. So based on the routing, it checks whether we did allow the policy or deny the policy, and then blocks at that level. So no IP address is involved here. And it also has advanced features like L7 based routing. And of course, added advantage is the observability with Hubble. So what are the methods we can use to install Cilium in the cluster?
with the help of Helm chart.
Okay.
And, and we can install it directly, like Cilium install. Like there is a command, so we can install it with the from our the CLI.
Yes. So we can install it with Cilium CLI, but that's not the production way of installing. So either you will use Helm-based installation, or you can use Argo CD to install Cilium as well. Okay. So during the bootstrap, you can install Cilium using Argo CD or Terraform also. With Terraform, you can still install the Helm charts. Okay. So these are the ways of rolling out Cilium in the Kubernetes cluster. So I think we have already answered what's Hubble. So I would reiterate on it, like Hubble is, it provides the network level observability, and it is a monitoring tool that is offered by Cilium. Okay. And then it also shows the dependencies and when the traffic is forwarded or dropped, all these details we would see. So as a recap, we would see it again, and as a continuation, we also plan to deploy some network policy and see how it works today. So does Cilium can replace kubeproxy? Any idea? Can it replace kubeproxy?
No.
Okay. Then if it still uses kubeproxy, then there is no point, right, of having Cilium. So, because kubeproxy by default uses IP tables.
Yeah.
So the answer is yes, it can replace kubeproxy. So instead of kubeproxy, it uses that eBPF program. So Cilium agent that is installed in all the nodes, that will do this work of routing. So whatever kubeproxy we have, it can be replaced by eBPF. Okay. So it can replace the kubeproxy because kubeproxy relies on IP tables. So we don't want to use them because of latency when the cluster grows to cluster grows to at least 100 plus nodes. If there is a enterprise level clusters, then it will be a problem of managing the kubeproxy. Yeah.
So in case of Calico, do we still need to use kubeproxy?
kubeproxy still uses, Calico still uses kubeproxy, and also it still uses IP tables. So that's why Cilium is popular, but it has the ability to use eBPF as well. So now they have bring in eBPF in Calico as well, but Cilium has that inbuilt feature. Like out of box, it is supported with eBPF. But in Calico, it is an opt-in feature. So that's why Cilium is more popular. But still, Calico is having that feature. Okay. By default, it was opinionated that Calico uses IP tables and Cilium uses eBPF. Clear?
Yes, sir.
Okay.
So ma'am, when we set up the initially cluster, so we don't like if we are using the Selenium, so we don't install the kubeproxy, right?
Yes. So there is an option to replace kubeproxy.
And if we are using both, so is there any issue?
No issues. The thing is, if you are using kubeproxy along with Cilium, then we are not taking advantage of using Cilium, right?
Yeah.
But that can be the case. You can still use Cilium just for network policy, but you can have kubeproxy as your CNI routing method.
Okay. And in the production level, if we are using the Cilium, so we don't use the kubeproxy, right?
Actually, it can. So you can still use kubeproxy and Cilium together. Okay. So that is technically it is possible. Okay. But then there is no point of having Cilium, right? Cilium has a greater advantage of using eBPF, and it can replace kubeproxy. Then in that case, you should aim to use Cilium instead of using kubeproxy.
Okay, and one more thing, yesterday we set up the UI. So in the production, we usually set up the UI for the Selenium or not?
Yes. So you can set up a domain for the Cilium, like Hubble.app, or whatever your or and then you can route the backend to your Hubble pod. Yes. So you be used to enable the Hubble even in production. But the thing is, you won't give access to all the application teams, because what they will do, they will check and then they will see that if there is a packet drop, then they will question you more. Okay, why there is a packet drop and all. But there are chances that if something goes wrong, it can have a bit of a packet drop. Like if it gets restarted, or no pods are available at that point in time. So it's better. So Hubble can be enabled as an UI, but only for the cluster admins.
Okay.
Okay.
I mean, like regarding the permissions, we use the RBAC. So only the specific users can access this UI, right?
Yes. So you don't open this for all the people. So just have it allowed only for the cluster admins.
Yeah, so how we can create this type of policy, like using the RBAC, like in the AWS we use the IAM role. So in the KTS level, how we'll set up these kind of policies?
Still, you need to integrate some of the mechanism. So if you are using Azure AD, then you can integrate Azure AD or IAM roles, and then have the IAM roles for specific people, assign it to them, and then only restrict access to them. So have access control for them. If it is an Azure AD, then you will have a AD group, and whoever part of that AD group, they will get access to that Hubble UI. So maybe you can just create a cluster admin group and then have them access this Hubble UI. So not everyone. So
Okay.
you can, so behind the scenes, it will, Kubernetes world, it is still the cluster role and cluster role binding. Okay.
Okay. Thank you.
Yeah. In the cluster role binding, you will add the group or IAM role, whichever you use in your organization.
Okay. Yeah. Thank you.
So let me see if we can discuss more on it. So now we have set up Cilium and we did the Hubble UI as well. But how do you troubleshoot? So how do you check? What are all the commands that you basically use to check whether Cilium is LT?
Selenium status.
Okay. Cilium status.
Yeah.
So that will give you the Cilium pod status, right? So Cilium, let me share. So I think yesterday we have seen Cilium status multiple times. So, and then you can visualize the Cilium pod status there and Hubble status there. But so does this going to give you any connectivity problem details? Like if there is a connectivity issue between pods, is it going to give that detail, Cilium status?
Yeah, I think. Not
I
sure.
think there is a command called connectivity.
Exactly. So we didn't discuss that yesterday, but so what Cilium status will give you, it will only give the details of the Cilium pods, not inside connectivity details. You cannot check anything. Okay, so is my screen visible?
Yes, Lord.
Okay. So when we did the Cilium status, it just shows whether the operator is up. So NY daemon set is up, Hubble is up, whether we did enable cluster mesh. So all these details it will give you. And then with this, what that means, it just means that we have all the Cilium pods up and running. But if there are any connectivity issues, you will not get that details. So, but ideally, how would you check? So if there, you know the from which pod to which pod you have connectivity problem, you can still check it in the Hubble UI. So that's the first point that you will check. So just check which application is having problem, and then you can check. Let me port forward. So I did run Cilium. That's why it is giving me this error already used. So I'm just going to kill the process. So choosing the demo namespace. So the thing is with the local setup, so it does not give you, at times it does not give you the details, right routing and all. Let's see, I can debug. But the intention is we can check it from the Hubble UI, and the other one is you can check the events, but there is another advanced level troubleshooting, like you can create a debug pod and then do a TCP dump. So that's the lowest level of debugging that you do. So you connect to the application and do the TCP dump and visualize and then debug the traffic flow. So that's how you troubleshoot in the live production. Another simple thing that Cilium offers is Cilium connectivity test. I don't think we can run that because it is going to spin off lot of pods. So it is going to create some sample deployments, and then it does a DNS test, and then it will give you a report of whether your routing is working perfectly or not. So since we are using a small time cluster, maybe it will work for some time, but you can explore it yourself. So what does it do? What's the advantage of doing this? And then you can also check the Hubble UI and for the connectivity issues. Okay. So this is how it will do. So it will crash our cluster if you do, because it creates a lot of deployments. Okay, so I'm not going to run that. Already my Cilium is overloaded. I guess it's not giving me the intended result what I was looking for. Yes, at least we got. So in the cube system, if you see, we have only few pods, so that's why it is like this. Otherwise, it will be a very much worst dependency graph. You will have to scroll down and then check into the right application. So basically, so this is our kube proxy, where all the DNS requests are coming inside this kube proxy. Sorry, kube DNS. So what is kube DNS? Can someone answer?
It's a DNS server where it resolves the host name while connecting with the service.
The Kubernetes, right? Exactly right. So it's the Kubernetes DNS server. So all the requests will come in this kube DNS service. So that's why you are seeing a lot of connectivities from this. So if each and every request will come through this, and then it will get routed to. For example, Hubble UI will not directly communicate to relay, but still there will be a kube DNS in between. It comes to here and then it goes to the other pods. Same for the demo application. You will see multiple routings. Okay. So kube DNS is such server. So for example, if you do any network restrictions, so network policy, if you apply any network policy, but if you leave the kube DNS, what will happen? Which we did yesterday. Any idea? So no host found, right?
Yeah.
Because we didn't allow the kube DNS. If you don't allow kube DNS, then all your DNS resolution will be blocked. So it will not identify where to go at all. So no host found or no root found, or those results you will get. So you should always allow kube DNS. Okay. So in the production, by default, you should allow kube DNS. And if you are using observability, you should allow Prometheus and Grafana as well. And if you are using Istio, you will have to allow Istio as well, because these are mandatory for every application to be connected, right? So if you do allow only kube DNS, still your application might fail if you are using Istio. So if you are not getting any metrics in a metric server like Prometheus or Grafana, then that means you are not allowing that metrics as well. So basically, you can either allow the application level or complete namespace you would allow. So basically what in the production environment, what we will do, we will include queue system namespace by default, and then monitoring namespace, Istio system namespace. So these are the three primary namespace we will include. So that there will not be any restriction. Clear? So that's how a simple production setup will look like. But if you have some other tools, then you can include them as well. Yes, Varna.
Yeah, Lavanya, I am having a doubt. So if we start using the Cilium network policies or any other kind of network policies, so the pods must be explicitly mentioned whether to allow or deny the network between pods. Am I right?
So by default, it is allowed. Okay. By default, pod-to-pod communication is allowed. Even if you install Cilium, we don't have any restrictions, right? But you will have to have a deny policy, cluster level deny policy. If you enable, there will not be any communication between the pods, between the namespace. Okay. So basically, if you have a deny policy, then you have to have a allow policy. So from which namespace to which namespace you are allowing communication. So yeah, it's based on the policy that is being set at the cluster level or at the namespace level. So there are two types of policies. So one is at the Cilium cluster network policy, another one is Cilium network policy. So these are the two policies. So yesterday we have seen, I think, network policy. Yes. So yeah, so two types of policy. So deny will take more precedence. Okay. If you have a deny, first it will take deny. So if you deny all traffic, it will be denied. But if you allow only a few namespace, then on top of the deny, it will allow only that specific communication between these two namespaces. Okay. So that's how the precedence is. But I would want, we can't discuss all the Cilium network policy types. So I think a quick task is, you have the Cilium installed on the clusters, right? So we have the lab setup. So just to go through this and then go through this network policy session. So here they are mentioning all types of policies. So yesterday we saw L3, L4 and L7, right? So each and everything they have mentioned the policies. Okay, just to take it and then apply it. For the front end and back end, have just on deployment and then label it as such, like back end or front end, and then see how where it is getting routed, so where it is getting blocked. So ideally you will see something like this. So this is all allow. Okay, this is all for packet is forwarded means there is no block. Okay, so the identity that I was telling is for the relay, this is the identity 7370. So there is no pod. So you are not mentioning any relay pod IPs. So it's all based on the identity. How this identity is assigned, it's based on the labels that we set. So that's why we are setting labels for each and every deployment that we want to allow or deny. So it's all based on labels, and each and every deployment will have a identity assigned in Cilium. Okay. Are we good with this? And destination will have its own identity. So from where to where it is sending the traffic, it will have its own identity, and with that identity only it can communicate, or it can allow communication or block communication. Okay, let me check if I get something for the demo.
And one doubt, Lavanya. So for Cilium enforces network policies only between pods, no? And Kyverna during admission of any kind of deployments. Am I right?
So these two performs two different work. So CNI is for IP address management, network policies, and tracing whatever the network issues that we have. So observability. So these are done by our Cilium CNI. Okay. But Kyverno is a different thing. So it is a policy. Okay. Policy engine. So policy means, for example, if you are, if you want to deny say privileged pods. Okay, if you want to deny any application which does not have label, so we should have label, right, for allowing this identity based solution. So we should have, every pod should have the label. So if we are allowing some deployments without any label, then it is not going to work, right? So then there is no identity based mechanism there. So what you can do, you can create a Kyverno policy to check each and every deployment has a label assigned. So if you create a deployment without any label, then that resource will be blocked, saying Kyverno has blocked your resource during admission. So during the admission, it will check whether it has a label, and then it will block that. So that is during the pod creation. Okay, the CNI will come in when there is a existing pod that tries to create a communication to another pod. Okay, so during the admission, so it not only the admission, so it can, so there are in Kyverno, there are different types of policies like admission, validating policy. Validating means just validate there is a label or not, but allow the creation of pod. Okay, if you validate there is no label, then you can add one label. So that type of flexibility it has. But yeah, is it answering your question, Farna? But we are going to see this Kyverno in detail. So how it will work. But on the high level, Cilium is during the networking layer. Okay. But Kyverno is at the pod creation, whether to allow the pod or not, whether to allow the deployment or not, whether to allow any resource. Okay, for example, I don't want anybody to edit their network, resource quota. Each and every namespace will have a quota, right? I said yesterday. So if they are trying to edit the network quota, resource quota, then do you think it will work? If you have a Kyverno policy to block, it will not work, right? So then it will, then and there it will show you are not allowed to, whatever message you put it in the Kyverno policy, it will show you are not allowed to edit the resource quota. So just contact the so and so, and then we can sort it out for that. Did that answer, Swana?
Yeah.
Yes.
Understood. So just like in Kyverno, we have this audit mode and enforce mode in Kyverno, right? Just like that, do we have such enforce and audit mode for Cilium as well to enforce for policies?
Yes, but by default, what we do now, we are allowing and denying the policy. So there are two types of things, right? But if you want to evaluate, you can completely have it at the cluster level to audit. So you don't, for example, I have the existing cluster, I don't have any policy applied. Okay. So in that case, you can just enable in audit mode and visualize what traffic is going where, and then you can deploy a network policy. So audit mode can be enabled.
Yeah, got it.
Okay.
Quick question, Lavanya. So we are talking about Kyverno, is it? Kyverno. Is it used for the security purpose? I've heard about this tool, but haven't got any much experience into it. So
yes, I think, we are fast forwarding here. So we have a different session for Kyverno.
Okay.
Kyverno is mainly a policy engine.
Policy engine. Okay.
Okay. So why do we need a policy? So we want to check. So we want to check whether we want to allow any resource or block that resource. So it is for validating, mutating, generating, all these things. For example, if you want to allow specific container registry, then that can be one of the use case for Kyverno policy. Okay.
Okay.
So as I said, it is a policy engine.
Okay. So this is one of the tools that we will cover later, correct?
Exactly. Yes.
Okay. Great. Okay.
Right. So, and then if you have some resource, each and every pod will have CPU and memory assigned, right? So there are teams, what they will do, they don't know what is their CPU request and limit. So they will just like that, they will not put anything in there, and then they will create a deployment. So what will happen if there is a huge load for that application, then it will crash your entire server, because it is going to, if you have an HPA, or like it can consume your entire node's capacity. Okay, so then the node can not serve other application pods. So in that case, it will be one of the problem, right? So such problems can be addressed by Kubernetes policies. So basically, if you see any problem, see through that if it fits your Kubernetes requirement, and then you can create a policy to stop that problem. So basically, it can be addressed using Kubernetes. So it's not so complex. It's Kubernetes is just an YAML configuration to allow these policies. Okay, but we are covering Kubernetes. So we'll see the Kubernetes architecture, what it can do. We can try to create a validating, mutating policies. Yeah, that will be there in our class. I think we should start today. So I just want to tell one more thing with Cilium. So there is a feature called Cilium cluster mesh. Any idea what it is? From the name you can respond. Cilium cluster mesh.
Kind of service mesh it is.
Okay, partly correct, yes.
For maintaining the whole Cilium cluster, something like that.
Okay, any other guess? Okay, so I have two clusters. Okay, I have a cluster in West Europe. I have a cluster in Southeast Asia, right? So these two clusters, can they talk to each other? Any idea by default, can they talk?
No, Lavanya.
No, right?
Yeah.
But with Cilium cluster mesh, you can allow these two clusters to talk. So how we would do that? So we will have an additional YAML file creating Cilium mesh. So, but the prerequisite, both clusters should have Cilium CNI. Okay. And then in the master cluster, what we will do, we will have an YAML. So if there is this pod is down in one cluster, West Europe is the primary region. Okay. And your Southeast Asia can be your DR region if in case if there are any disaster happen, if the application is down. So we can route the traffic to Southeast Asia. So in that case, it is a DR scenario, right? So DR scenario can be achieved using Cilium cluster mesh. Okay. So basically, if you can configure whether if this pod in the primary region is down, it can go and reach the Southeast Asia and then get a response from that. Still, there will be a lot of latency, but application down is not good rather than having a latency, right? So that can be achieved using Cilium cluster mesh. So I don't think we can perform a Cilium cluster mesh with our kind cluster. So, but there is a feature that have that in your mind, okay? But it's not that difficult to achieve. So it's just all YAML configuration. So if there is such requirement, there is a concept called the cluster mesh that you just know. So now someone can answer what is Cilium cluster mesh at least. If you
Maybe like to enable communication between two pods, between two clusters in different regions.
Yes. So for that, what is the prerequisite? You should have Cilium installed in both the remote clusters. And then this is called as cross-cluster traffic. Okay, this cross-cluster traffic will be routed based on your configuration. And all the traffics are encrypted in Cilium. Okay, so you can, there are different encrypting mechanisms like IPsec and WireGuard. So these are some of the famous encrypting mechanisms. So you can configure any of this when you deploy Cilium. Okay, and then so you don't need to worry about what is inside this encrypting mechanism. Just choose one which is widely used, like IPsec. That should be more than enough. So using IPsec, you can encrypt the traffic. So cross-cluster traffic will not be unencrypted. Okay. So the flow will be cluster A. Then it has its local Cilium, and then if there is a configuration that it can reach the remote Cilium, then it will go through this encrypted tunnel, then remote Cilium, and then cluster B. That would be the flow in case of Cilium cluster mesh.
So I think we will be using Cilium cluster mesh during DR environments, DR environments. If that's the case, does the secondary region should be in active state?
Basically, if you are managing 3 clusters already, so don't consider DR at all. So you have a huge application base in West Europe and you have a huge application base in Southeast Asia. So do you think that you will have one cluster?
No.
No, right? So you will manage 2 clusters differently. So this is not actually a DR scenario, but this can be configured in case of any application outage. Okay, that's what I'm saying.
Got it.
But what you can do, you can also imagine like you have a West Europe cluster. So during the DR scenario, you can spin up another cluster also and then enable that cluster as in a cluster mesh and then you can reconfigure. Got it? It does not need to be an active setup. So you can set up another cluster as well and then have cluster mesh for the new cluster that is being running. Okay. In that case, your primary cluster will be down and then your it can route traffic to your the second cluster that you have just spinned up.
Yeah, got it.
Okay, but no, that's not widely used. So basically, we don't allow traffic between these 2 regions. So I'm just saying, if you have 2 clusters, you can still route traffic. So that's what the intent is. So there are something like a Data Protection Act, right? Data Protection Act means, so that, for example, if you are using an US cluster, so you cannot have a database data in other regions. You cannot copy the data from Europe to US. So that type of restriction you need to follow. So based on the Data Protection Act, which region you can communicate, like which is allowed as per the law, then you can allow the traffic. So you cannot just like that allow from US to West Europe, right? And also you cannot take the traffic from some other region where the data protection law does not allow. So those things you will have to consider. So technically this will work, but underlying things in all based on the decision of your organization, whether we can allow or what type of application that you are running. Is it a PCI like payment application? So it has its own compliance standard. So that you need to follow.
Yeah, got it.
Okay. But yeah, the behind the scenes, the Cilium cluster mesh is nothing but you can combine 2 clusters. That is the feature that it provides. So that was interesting when we did a migration from one cluster to another cluster on the same region. So we didn't so it's not, don't consider that as a DR scenario, which I said, but I had an experience in migrating one cluster to another cluster. So due to some restriction, so we were using Calico in that cluster. So we wanted to migrate to Cilium. Okay. So in that cluster, what we have done, we have temporarily allowed traffic from that the source cluster to the destination cluster. Okay.
Yes, sir.
Okay, so it doesn't need to be on the different cluster. So due to some restriction, for example, if you are reaching your network, virtual network to maximum usage. For example, I am running hundreds of nodes today and my cluster is almost full. I cannot spin up a new node, right? So this is where you will have to build a new cluster. If that type of restriction, if you come across, then what we do, we will create a new cluster. And then during the new cluster creation, you cannot do a traffic routing by making an application down for 1 week or 2 weeks until you sort out all your issues. So in that case, what will you do? So you will still run your primary cluster, but just route the traffic to secondary cluster from the primary cluster itself. If it works, fine. If it not works, then you have an option to roll back.
Okay.
Yeah. So in that would be one of the case I would say. So in the same region, cluster to cluster migration. That is one of the use case. But when you say different region, then the data protection will come into picture. If you answer something like this, then there will be definitely a question on data protection. Okay. So just remember in mind, like it can use, okay, it can be used for cluster migration on the same region. So basically a new cluster creation.
Yeah, it's clear.
Okay. So I think with that, we should move on to the day 2. And I think we have done all the recaps already. So I think someone has asked about eBPF mode yesterday. So I just added few notes here. It's a small program to run inside a Linux kernel. So capabilities, again, we have discussed more and more already. So it's for network observability. And then you can see the packet level filtering, and then you can modify the behavior, and you can, yeah. So these are the capabilities, eBPF capabilities. So the
Yes, in is stuck at Hubble UI.
is it? Okay.
Yeah.
I share the entire screen today. Let me see.
Yes, now we can see the eBPF.
Is it? Okay. Maybe some lag. Okay. So traditional, so just a recap. So don't mind that I'm saying again and again. For some of you who know already, that's fine. But some of you who doesn't know, right? So that's why I'm just reiterating on the same topic again and again, just to remember what is what, so that you don't forget. So that's why I'm just having a recap session every session before, even after Q&As. Okay. So the traffic flow from in the normal Kubernetes networking with IP tables, that's what I'm saying. So from pod, it goes to Linux kernel and then IP tables and then reach the destination pod. Okay. That's how it is. So what is the drawback of it? So due to the IP table, it gets updated in a sequential manner, then there will be a huge latency when the cluster grows. Okay. So then it will be like complex in debugging. So that's one of the challenge. And then you will have to do a multiple kernel calls. So that's also another overload. And then you will have high latency in the large cluster. But when it comes with eBPF, you know the advantage no more now, right? So front end pod goes to NIC, and then here the eBPF program will be invoked. So we did allow the traffic using network policies. If there is a deny, then there you will see packet drop, red mark in the Cilium saying that packet is dropped. Okay. And then, so basically the terminologies that they use in Cilium. So we didn't use that specific terminology. We just understood in the layman terms. So XTP is express data path, which means high performance packet traffic processing will be done. So that's how they say XDP. So these are the terminologies. And then TC is nothing but your traffic control. Okay. And K-probe or trace points, they will say something like this. It's kernel level tracing. So these are the terminologies. Just don't think it is more. Just understand it's basically for debugging and monitoring. Okay. So advantage of CDM, again reiterating, it runs at the kernel level. And you don't have to complicate your things, like you don't have to make a system call type of restriction. So it will automatically take care of for us. We don't need to do additional configuration. And each and every programs like allow or deny, all these calculations, it will be done at the sandbox level execution. So each and every program will run in a sandbox environment at the kernel level. So no need to invoke a separate kernel module changes. Deep observability using Hubble and then dynamic network policy. So you can define the network policy during the execution. It will check whether it is a block or allow or audit. Then based on that, it will route the traffic. Okay. So the main, what are the tools that are mainly using eBPF? It's Kubernetes for Cilium. We are using for Kubernetes networking and Hubble for network observability. So Hubble itself is a separate tool. It is integrated with Cilium. It can be integrated with some other tools as well. Okay. So don't think that it is only for Cilium. It's one of the Cilium feature. Okay. eBPF is not also one of the Cilium feature. We are just taking the kernel level advantage and using that in the Cilium. So, and there is another tool called Falco that is also running on top of Cilium. So that Falco is also getting more and more popular because the selling point is eBPF. So just comparing IP table again, yeah. So we have already seen it many times. And then Cilium observability, it gives you low visibility DNS monitoring. So which DNS is allowed and which DNS is blocked, that type of monitoring you will get. And then HTTP and UDP based traffic can be sent, and you with the Hubble you can get the trace. 1 minute, my son is here. Yep. So tracing and policy level debugging. If there is any policy that is blocking your request, then you will know it in the UI, or you can just describe and then see investigate more there. Okay. And you can also debug the network flow logs as well. Yep. So again, I want to iterate on again eBPF high performance networking identity based assignment, which we have seen now. It's based on the label, and it can do the queue proxy replacement, so which we discussed. And then Hubble provides deep observability and service mesh, so it can replace service mesh as well. Okay, so you don't need to have additional tool for service mesh, so you can make use of Cilium itself. So you can replace the Istio service mesh with Cilium service mesh, but see, Istio has its own advantage which Cilium cannot offer. So that's why some people will have Cilium as well as Istio because of Istio's advanced features. But it has the feature of service mesh as well. Okay, cluster mesh, service mesh, all these are provided. And yesterday we were talking about ingress controller, right? So instead of having an ingress controller, your Cilium can handle. So for ingress, it has a gateway API. So that is one of the replacement of ingress. So just imagine how many tools it is getting replaced. So it has the feature of ingress, and then it has the feature of service mesh, it has the feature of cluster mesh, and then it can replace the queue proxy, and then has an encryption with WireGuard and IPsec. So for any cross-cluster traffics, and then it provides network policies. Okay, in replace of Kubernetes network policy. So Calico can also provide network policy, right? But your CNI should support network policy implementation. For example, if you are using a Flannel, it does not support network policy. Still, do you think that we can still use Kubernetes network policy? No, right? Because your Cilium does not support it. But when you enable Calico or Cilium, then you can enable Kubernetes network policy and use them. So you can use the Kubernetes network policy itself, but we are taking advantage of Cilium network policy itself. Got an idea? Maybe it's a little bit confusing here. There are two types of policies. One is Kubernetes network policy, and another one is Cilium network policy. So far, we have seen Cilium network policy in our demos. So there is something called as Kubernetes network policy.
See, Lavanya, one quick question. So not every client will go for Cilium, correct?
Yes, if they have been running the cluster for quite some time, maybe for 3 years or something, then they can still use whatever CNI they want. And if their cluster is very small and they don't have this much complex requirement like having a mesh or having a cluster mesh, or if they can use of queue proxy, then that should be enough, right? They don't need to go for the Cilium and make it complicated. But you have to manage the Cilium. You'll have to do the upgrade of Cilium. You'll have to make sure Cilium is always up and running. So during the Cilium upgrade, your cluster can go down if you do a misconfiguration, if there are some deprecated features that you are using. So that much of work and complexity it has. So if okay with the basic queue proxy, small cluster, small environment, no issues, then that would work forever.
Yeah, one thing what I've understood in my current project is, see, there is only one cluster. It's a SaaS product, okay, SaaS product, and then the application services runs under only one cluster called upstream. And I believe they're running only on kube proxy. We don't have any CNI over there. But is it normal that a product running with some only 50 services not much complex things and directly connecting to async and database side. Is it quite normal that the people use go only with the kube proxy and they don't overcomplicate it, or
Yes.
that's
So
how it works?
as you said, it is a single cluster, right? So it's not an enterprise grade cluster, enterprise scale cluster. So if in an enterprise scale cluster, you cannot just have a single cluster. You need to have multiple clusters, right? So if there is a problem, then you'll have to have a replication mechanism on some other lower environment, exact replica of it, right?
Yeah, but this is the cluster is developed from the AWS only, so EKS.
But if there are any issues, then it is okay to take downtime, right? In that case, so there might be. So it's all based on the client. So this is all enterprise scale setup, Ganesh. So
Yes,
it's not for the basic Kubernetes cluster setup. So all
Mhm.
these Kubernetes and Cilium, Istio, and then what else? So we are covering a lot of tools, right? So we don't need any of these tools as well. You can just create an AKS or AWS cluster, and then whatever is there by inbuilt. So you can use their own CNIs, AWS CNI and Azure CNI. Just make use of it. It can use the kube proxy and it can run the cluster. There is no harm. But what we are covering is enterprise grade setup. We'll have to think of all the features and then what is the advantage that each tool is providing, and we are making use of it.
Agree. Okay, thank you.
Clear, right?
Yes.
Yeah.
We are actually moving for one of the client. We are doing it fully on-prem Kubernetes, where we are considering all these things.
Okay. Yes, I think when you do the POC, you need to consider, because your application will not be at the same state, right? At some point in time, it will have a huge scaling, right? In that scale, you need to consider having, at least a service mesh. Not you don't need a Cilium, but you need to consider having an Istio for advanced level of traffic routing.
Yes. At least service mesh, right? So that's what I was.
Yes, at least service mesh, at least monitoring, and at least policy as a code using Kubernetes or OPA. So yeah, these are at least.
Yeah. Okay, thank you.
Okay, so let's come back to the network policy. So if you enable Cilium or Calico, you can still use this network policy. Okay, this is Kubernetes network policy. So you can get the details from the Kubernetes document itself. So this will have both ingress and egress policy. So IP based routing and allow or block is allowed. So this is ingress. Ingress means ingress allow. Ingress deny means ingress deny policy. Egress deny means egress deny. So this is an allow policy. Okay. So this is for the IP level routing, and then this is for the namespace level segregation. In that namespace, only selecting one of the deployment. So you got the point, right? So basically, an ingress, it will accept the ingress. So this test network policy, this DB will accept the ingress from front end part in the namespace my project. Okay. So the concept will be same for network policy, even in Cilium or with Kubernetes network policy or with Calico. So all that it changes is this API. Okay, API and some syntax. That's it. So we can still make use of this. Okay. But what we are using in our labs, we were using Cilium network policy. Where is it? Yeah, here it is. So we were using Cilium network policy, right? So this is also doing the same thing. So for example, if you see, so this policy is for what? The front end egress policy is for Nginx front end, which we saw yesterday. And then it just sends traffic to kubedns. I was saying that kubedns should always be allowed. And then which port? 53, UDP and TCP port. So this is completely for kubedns, allow traffic. Okay, so this is at the L4 level. L4 means port. Okay, L3 means IP. So to any CIDR or single IP address, you can use the 2 CIDR and then configure L3 level traffic. So yeah, just a minute, Swarna, I'll finish it up. Okay, and also you can allow traffic to L3, yes, L7 based, like for every domain you can allow. For example, I don't want to allow traffic to external world. Okay, I don't want people to hit google.com or some spam websites are there, right? So you don't have to reach those websites. So all that you need to configure is what domains you can reach from that pod. So front end pod can reach google.com, it can reach github.com, and it can reach this matrix view, which is your organization level URLs. So you can configure to allow traffic to only to this. So if you allow traffic only to this, then rest of the traffic will be denied. Okay. And so now we are configuring which traffic it has to allow to egress. Okay. And then two endpoints means to which, from front end to which pod it has to allow. So we are allowing the traffic to Nginx backend, and then at this port, and L7 means you can configure rules like get or post or all these rules you can configure to some endpoints. So this much minute level of traffic routing is possible with Cilium. So, but if you see FQDN based traffic routing in the normal Kubernetes, you won't see it. But still it supports L3 and L4, which is basically your port and IP. That type of traffic it can allow. But advanced level traffic routing like this, like L7 and 2 endpoints and FQDNs to single specific IP. So, or for specific host name also, it can send traffic. So these minute level of details, we can do that with the Cilium network policy. So just that the concept is same, but you are using Cilium API and then you are taking advantage of L7 level of traffic routing. Okay. And then you are denying a traffic to egress deny. So explicitly deny to some of the pods. Then you can mention which label, to which label it has to deny. Okay. So this is another example. It's very simple. So from the front end pod, we are allowing to pod allow demo. Okay. So if there is a namespace called allow demo. So all the traffic from front end will be allowed to allow demo namespace. Okay. Another policy like all the front end pod will allow traffic to will deny traffic to deny demo namespace. Clear? So it's basically it just allow or deny. So allow means you just select the namespace and all the pods inside that namespace will be allowed. Deny means it will deny the traffic to that namespace. So any namespace, you cannot reach that namespace at all from your source pod. Source pod is your endpoint selector, which is Nginx frontend pods. Yes, Swarna, you did raise a question.
Yeah. Earlier we were talking about CodeDNS, KubeDNS, no? So what is the difference between KubeDNS and CodeDNS we have in Kubernetes?
Both are same. Okay. So okay, got it?
Okay.
Hmm?
Yeah, I got
So
it.
basically, KubeDNS was the original inventor. So 5 years back, you don't see a CodeDNS pod. Instead, you see KubeDNS pod. Okay, they renamed the front end alone. The behind the scenes, it's KubeDNS. So if someone confuses you, what's CodeDNS, what's KubeDNS, both are same. It is a DNS server for your Kubernetes cluster. Okay, that's it. So that's why we are using kube system namespace, and then this is the lane. And then of course, for the DNS server, it is running on port 53. Clear?
Yes, Lavanya.
So since we are already out of time, what I would like you to do, so just do a lab task, maybe before coming to next session, then we can discuss more questions. So I want you to install Cilium, install Hubble, port forward, and then explore traffic allow between two namespaces, explore traffic to specific IP. Yeah, and then what not? Like just explore this L3, L4, and L7. So each and every example, you try one. So for L4, you try one for ingress and egress. So that's your lab. Okay, we can do that now, but you will see issues with Cilium cluster every now and then. All you have to do is just redeploy the lab again and then see how it works. Okay, it should work, but we don't have time to debug right now, but you can do that later. And then I have included all the lab details even in the today's session. So yeah, so it's on the same repo. So every week I'll create week 1, week 2, and then each week will have its own README file. Go through the README file. So this is for day 2 demo of Cilium. So install Cilium and then create a front end and back end deployment, and then label the deployment. Just after that, test the connectivity. So it is until the test connectivity. Now your work is to create some network policies L3, L4, L7, FQD, and DNS. So all these things you will have to explore and then see what you are seeing in Hubble. So basically what you should see in Hubble, Cube system. So it's all allowed, it's all forwarded, right? So you will see dropped. Instead of forwarded green, you will see a red drop, and then there will be a connection cut here. So yesterday I have shown you, right? There is a red mark. That means a connection is dropped with the help of network policy. So you'll have to hit the curl command to check the network connectivity. Okay. So do that before coming to next class. If you have any question, just post your question in the WhatsApp group as well. If I can respond. Oh, still we have, I think for some of you who are interested in Calico versus Cilium, just I think we discussed it more. I don't want to go over again and again. Yeah. So I would like to take a break here. So 15 minutes break, and then we will see what is cluster and cluster context. Okay. Yeah. See you at, now the time is 11:40. Okay, after 15 minutes, I'll see you at 11. Okay, see you. Bye. Hello, are we here? Okay. Okay. I was checking if we could see the traffic flow in Cilium, but still it is not, my cluster is not responding. So it's fine. We could continue with the other session. Maybe you can try that yourself. So let's start. So we are going to discuss about what is cluster and what is context. So we haven't discussed about the kube config. So we are going to discuss it now. Okay. So this is main. So this is how we authenticate to cluster. Okay. So basically, what are the cluster components that we have seen? We have seen control plane worker nodes, right? So apart from that, what is that segregation thing that we have, which is namespace, Kubernetes namespace. So then coming to the cluster. So what does a cluster mean?
Group of servers.
A group of nodes, okay? Not servers, group of machines. Of virtual machines forms a cluster. Okay, so how a cluster will be identified? So cluster will be identified using the API server address of the cluster of that Kubernetes cluster. So API server is nothing but your control planes, where your control plane is running. For example, in our kind cluster, you will see this as your cluster API address. So it connects to your local API. So which is 57759. But in production case, you will have a different name here, and in Azure or AWS, you will have their naming convention that's followed. So this is the API address, API server for your cluster. Okay, cluster is nothing but a group of machines that forms a cluster. What is the how the cluster will be identified? It's identified with the API server address. Okay, which is in our case, it's the local cluster. Okay, so what are users? So why do we need user at all? So we need user to authenticate to the cluster, right? Basically, for authentication, we have to have users. So these users can be local user. For now, we are using kind cluster. That's why we might see a local user. But in production case, what are these users? If it is an Azure integrated environment, it will be AD user. Okay. So using that user ID, you will be authenticated to the cluster. And what is a context? So you know what is a cluster now, what is a context now. And you also know what is the namespace, right? So cluster is nothing but Kubernetes API address, and there so you can download multiple clusters configuration onto your machine. So you can have dev cluster, staging cluster, prod cluster in your local configuration, and you can switch that clusters by just using some simple commands that we will see right now. Okay, so basically what a cluster has, so cluster will have a name, and then it will be mapped to the right API address of that cluster. So this is the cluster configuration. And then what is a context? So context is nothing but on which cluster, on which user, and on which namespace. So these three combine together to form a context. Okay, so for example, in dev cluster, I have dev namespace. Okay, so this is a dev cluster, and then I have dev namespace plus what is the user? I have a dev user. Okay, so this is one of the contexts. So all three combine together to form a context. Just the cluster name will be your cluster, and then how a context will be framed by combining the cluster plus user plus on which namespace he is checking. So that is your context. Okay, by default, your cluster will only list the default namespace details. Like for example, if you do this kubectl get pod, so this will give you default namespace details. Okay, so KGP namespace default. So by default, it maps to the default namespace context. Okay, but if you can still change the context to different namespace like cube system. So whenever you give KGP, then you will get all the pods listed in cube system. Okay, for that you need to change your context. That we will see now how we are going to do. So how a context will look like? So it has to have the cluster name, and then which user and which namespace. So far we have listed the pods, right? So far it might have been in the default namespace as the default context. This can be changed. Okay, so how we will change that we will see in a bit. Any questions up to this?
No, Lavanya.
Yeah, so this user is a particular user or like any of the users which we configure or create in the cluster?
Basically, it is you. So for example, if you downloaded the kube config by authenticating to the cluster, right? So you will have your ID. So basically, if your ID will be mapped here, who is the user, your name will be mapped against it. But for our local setup, it will be a different user by the default user which kind cluster creates. So that's how we will get authenticated. But in a production case, it will be you. So you are the user.
Okay, means in case I'm using Azure, so my Azure AD will be mapped here.
Yes, exactly.
Okay.
That's how you authenticate. That's the user. Okay. So we will see what is kubeconfig. But these are the commands that we will use. So basically, a kubeconfig will have this structure. What's the cluster? What's the user? And then what's the context? Context will be adding the cluster plus user plus namespace. So this is how it will be for each and every cluster. So you have 10 clusters. You have downloaded 10 clusters kubeconfig. So your kubeconfig file will be very large because it has all the server details mapped to it. So you can just switch it and connect to that particular cluster. Okay. So I will show you what is kubeconfig has. So this is going to show me a brief level detail of what cluster we have. So currently I have kind, Cilium, kind, demo, gateway, lab, minikube. So these are my 5 clusters. Okay. So these are the cluster details. And then what namespace? So now, so the star represents which cluster is my current context. So KGP, it will give me the pods in kind, gateway, lab cluster. Okay. So I have to switch to some other cluster, right? So if I have to switch to Cilium cluster, let me switch. Okay, and check. So config use context and then find Cilium. So okay. Anyways, the pod is the cluster is not in running state, but still it is connected to. So it's still its context is changed to kind Cilium cluster. So if you see now the get context, yeah. So the context is the cluster is switched to which cluster? Kind cluster. So it was previously gateway lab cluster. So now it is switched. So you can use this command to switch the context. Okay. So what will happen? A question. So what will happen if I delete the context? Can someone tell me what will happen if I delete the context?
Whole cluster namespace and user gets deleted.
Okay. Then that's too risky, right? So now you tell me what's the difference between these two? Kind, delete, cluster, kind, Cilium. What does this do?
It will just delete the cluster.
Okay. Then what does kubectl config delete context will do?
It will delete from the kubeconfig file, I think.
Right. So I think Suchitra, you are following. That's why your answer is very much correct. Like basically, sorry, it's not correct, but I'm saying that your logical thinking is correct. Okay. So it is not going to delete your cluster. It is just going to delete the context that is mapped in your kubeconfig. So the cluster will still remain. Okay. So I'm not going to run this delete command now. So first I will delete context. So now I will delete my Cilium. So I have deleted the context. Okay. So it is showing me that it is deleted from this config. Okay. But if I list the cluster, first let me list the context now. Config get context. So now my kind Cilium is gone from my context. Okay. But my kind should still have the cluster. This is the command, I guess. What is the command? Kind
Get clusters.
Get clusters, is it? Okay. So I have only these 2 clusters, kind clusters. But if you see the kubectl, it has lot of clusters where it is having some dummy entries as well. I deleted the cluster, but I didn't delete the context. So you get the point, right? So these two are 2 independent things. So you can the cluster is different and context is different. Okay, the cluster is going to be residing in some cloud or some on-prem. Okay, you cannot delete the cluster by deleting the kubeconfig. So how? So the cluster configurations like this config file, we are deleting it from the local, not from the actual cluster. So using kind, we are deleting the cluster. Using kubectl config delete context, we are deleting only the config of that cluster, not the cluster. Suchitra, did that answer your question?
Yeah. Got it.
Got it, right? So yeah, and then you can switch the context using use context command. Okay, so if you want to see what are all the kube configs that are there, you can see it like this, kube config view. So then it will show you what clusters are there. So the kind cluster, kind Cilium lab, kind demo, kind etcd. So whatever clusters I have created from the week 1, it has all the cluster details. And then, so each and every cluster, if it has a certificate, then it will have its own certificate authority. But only Minikube has the CA. So that's why it has added the cluster authority. Okay, but in production, you will see this. So it has a CA cert, CA PEM and key file. All these will be mapped to specific production clusters. Okay, and the context means cluster, user, and the someone raised some question.
Why we use the certificates?
So without certificate, anybody can download the context, right? So each and every user, authenticated user, will have to have some authenticated mechanism. So that's why we have, it is giving tight security mechanism, right? So it is verifying its way of identifying the Kube API server, establish a TLS secure TLS connection. Okay. So to have the secure TLS connection, the CA certs, all these certificates are required. Okay.
Quick question. So if you scroll a little bit up, what was the command? kubectl context viewer.
Yes. kubectl context view, right? So by default, it will, your context will be stored in which location? Your directory /kube /config. So this is your file. So either you can use this command or you can just do a cat. Okay, to view the entire file. So now so these are all, it's a sensitive value. It's not displaying in kubeconfig view. But if you see the file, it will show all the details of what's the CA cert and all the details. Okay. So we were seeing the context. So context means cluster plus user. If there is no namespace mapped, then default namespace will be your default context namespace. Okay. So but you can still change the namespace. How we can change the namespace? So we have a command to change the namespace. I will show you how to do that. To the CTL context, use context. So if you don't know the commands, just I give --help. It should give you more details. So there are some other additional tools like kube-ns. So so if you install these tools, it will be so easy to switch between the contexts. You don't have to run kube config, switch context, switch the cluster, switch the context. You don't have to do much of it. Just install this and then you can just execute the command. Let me install it right now and see if it works.
Ma'am, I have one question. Like, suppose we delete the context. Okay. So can we still get the access of the cluster?
Yes, you can download the config again.
Achha, we need to download the config again. Okay.
So it's not deleting the cluster.
Yeah.
Have to re-download the config. That's it.
Okay.
Okay. Maybe you can explore this yourself and then install these tools. I don't want to spend too much debugging here. So yeah, putting that in the chat. So cube CTX. So if you have a cube CTX, KX, yeah. So just a cube CTX command will give you the list of clusters, and then I think namespace cube-ns, I guess. So using this command, it can switch the namespace. Instead of default, you can give cube system. But I don't have. I think I'm not in the right cluster. Which cluster? So if you use the tool, it's easy. So kube-ns means cube namespace switching. Okay. So just run the kube-ns and give the namespace. Now you will see AGP. You will see the pods running in cube system namespace because you switch the default context to cube system. So otherwise you would have been seeing the default namespace. Okay. Is it clear? So just install that tool and then switch the namespace easily using kube-ns. And then, so kube-ns, it will list all the namespace and what is your active namespace. Okay. And then cube CTX. Cube, I think I have an alias, so that's why it's not working. KX is cube CTX. So then it will show me all the cluster and which cluster is my current context. Okay, so this is just the replacement of cube config use context and then like get context. So this is just another replacement tool that you can make use of it. Just explore it when you get time. So usually we don't just use kubectl, right? We use K9heads, and similarly for context switching, people will be very pissed off to type the entire command every time, right? Remember the command and then if not, go and search and get the command. So why not use a shortcut? Like if you have such CLIs, just make use of it, and then we use this quite often in the production environments. Just switching between, because we have around 30 to 40 clusters, and it's very hard to type the entire command and then select the cluster name. Often we forget the cluster names also. So just using the cube CTX and then kube-ns, we switch the namespace and then work on it. So that's how we do it. Any questions in the cluster and context? It's not a big topic, but good to know.
I have one. Let's say we have multiple clusters. So whenever we download this kube config file, so it will append the file in the kube config. Means it will continuously append the details in the config file, right?
Yes.
Okay. So file will be single, and the details will be of all the clusters for which we have downloaded that.
Yes. File will be single. You can change the default file location, but it will be the single file. Yes.
Okay. Thank you.
Okay, so if I create any new cluster, what is going to do? It is going to, by default, it is going to download the kube config, and then it will add these details in the kube config. We are not doing anything. So just that we are just downloading the config. So kind cluster installation, it by default automatically downloads the config. But if your cluster is somewhere else, you have to authenticate to that environment and then download the kube config. Okay. So now if you see, I have so I've created a new cluster called Cilium. So it's a kind cluster, but so by default it downloaded the config just now, and then it appended that cluster as my default config. Okay. Is it clear?
Okay. Yes. Okay. Thank you.
Okay. Okay, so let's see a small lab how to do a backup and restore using etcd. It's again not an exact production replica, but just we are going to understand how to snapshot and restore it in case if there are any problem, how to restore it. So do we have any willing participant to share your machine and do the lab? Yeah, Swarna, go ahead. So before getting started, what is ETCD? I think Swarna, I know you know it, so I would call someone else. Suchitra, can you?
It's
Yeah.
a storage where we can where all the things get stored in the key value page. Whatever, if we are sending, if we are creating any pods, then those information it gets stored here. Like all the information, it's a storage where we can store everything regarding the cluster information.
Exactly. So yeah, we are following correctly. So etcd is a key value database in Kubernetes where your entire cluster configuration will be stored there. Okay. So what will happen if the etcd is down? Your cluster will be down. So it is one of the important pieces that it has to be up and running all the time. So that's why we are interested in taking a backup and restoring it. Okay. Yeah. So yes, Swarna, you can share your machine now, and then I will point you to the right place where you have to start. So under week 2, in the README file, you have etcd backup and restore section. I think I want everyone to follow the lab. Yeah. Yes, Swarna, you can share your machine. I'm not seeing your machine yet.
I'm sorry, I was on mute. Yes, Lavanya.
Yes. So in week 2 README, you have the same file, like search as etcd, you will find where to start.
Okay.
So which switch to code mode. Yeah.
Yeah. Or do we need to create a new cluster for?
Yes, better to create a new cluster.
Okay.
So we have created a cluster, and then we are creating 2-3 namespaces to check the snapshot, backup and restore. Okay, so we have, can you list the namespace now? Okay, so you have test2 and test3. So these 3 namespaces are there. Now go ahead and create a deployment. Okay. So now you do one thing. So yeah, you follow that document. So it has a. So for taking backup and restore, you need to have etcd CTL. So that's the CLI that we will use. So by default, this Docker container does not have it, and that's why we are installing this etcd CTL.
Lavanya, I have a question.
Yes, Raj.
Can you please explain that Docker exe, where the container is hosted?
Okay.
The etcd control plane, that one.
So were you there in the first class, Raj?
Yeah, I have attended.
Okay. No worries. I can explain you. Just etc. For now, you know what is etcd, right? It stores your cluster configuration,
Yeah.
right?
Yeah.
So where it is running, the etcd, it's running in the control plane.
Yes.
How it is running? It's running as a pod. Where it is running, it's running in the cube system namespace.
Okay.
Okay. So now in this lab, what we are doing, we are taking a backup of that etcd and then restoring that from the backup.
Got it.
Okay, that's what we
Yeah.
are doing.
Okay. Okay. I got it.
Yeah, thank you. Yeah. Thank you for the question. So now, Swarna, just go back.
Yeah.
So what we have done, we have just installed the etcd CTL, right? So
Yeah.
now, just pin another terminal. Okay, just keep it ready. Okay, so go back to the previous terminal and then create a snapshot now. So this is the command that we have to pass in to create snapshot. etcd CTL save snapshot db. So it will save in the current location. And for creating a snapshot, you again still need to authenticate, right? So which is the endpoint and how you are authenticating? You are authenticating using etcd cert and cert and key. So without this combination, your snapshot will not work. Okay. So now you have created the snapshot. Go to the another terminal, the terminal which you, yeah. Now, yeah, go back to the document and do that. Yeah. So now we are taking the snapshot and putting it in our host machine. Okay. Because we can't restore it inside the Docker, right? We have to do the entire cluster restore. So that's why we are copying the snapshot.db from the container to your host machine.
We have to be in the container, right? Now in the etcd.
It's fine. You can be there in the etcd, but you can run it in other terminal. Yes, do it here. Do it here. So you copied it to your home drive, right?
Yeah.
So it's not in the container now. So you took the backup in the container and then you put it in the host machine. So basically in the production environment where you will keep the snapshot.db, do you think we will keep the snapshot.db in the etcd control plane host? No, right? Because that host might be down. So you will have to have some mechanism to push it to some external storage. Like you have to have it in other machine or you have to connect to the AWS S3 or Azure blob storage, and then you have to ship this snapshot.db every day, like based on every 4 hours. If your cluster is doing too much of operation, you can schedule based on that and create a backup schedule using some jobs and then push this file somewhere safely. So because our control plane can go down, right? So you should keep this backup safely somewhere. So for our demo purpose, we have taken backup and then we have kept it in host machine. Okay, clear, right?
Yes, Lavanya.
Right. Go on.
Yeah, Lavanya, for cloud one, like etcd is managed by the cloud provider. So there also we can download this particular database because
Yes, you can push this file snapshot.db. So you can create a folder or every day and then push this snapshot.db to that cloud storage. So
okay,
every
so we can take the snapshot and then capture that particular file only.
yes, take the snapshot using etcd CTL and then ship this file to the storage, cloud storage or whatever storage you are referring to. Yes.
Okay, so
So now you do one thing. So you'd have taken the snapshot, right?
Yes.
So now you create few namespace, few deployments. Okay, create a deployment in test5 or test6 namespace. No worries, just create the deployment. Yeah.
Lavanya, a quick question in between. So every week's lab, we can always start from scratch, correct? It doesn't need a sequence from the previous lab or something like that.
Yes.
Okay.
All that you have to have the CLIs, because every lab we are creating a new cluster using kind. Okay. So it's not the continuation.
Okay.
So, and also do one thing, Swarna. So just paste the same command, just control V. Okay, remove the test5 namespace and change the replica to 2. Okay. Okay. Yeah. Hit enter. So now
we are going to create in default namespace.
yes, we are scaling down in the namespace, in the default namespace. Okay, it's scale command, not create command. And also you don't need to mention image. Because it's already existing. So for create only you need to pass image. Yes, that's enough. So you scale down. So what we did, we created a deployment in default namespace with 4 replicas, and then we created few namespace. We have taken snapshot. After snapshot, we created few more namespace, and then we scaled down the default app. Okay, the app in the default namespace. Okay, so that's what we have done. So now you go ahead and restore the etcd. So go back to the document. So now you are there inside that Docker, this thing, right? In the first, yeah. So here you need to run that. First, from the first itself, not only that, because if your kubelet is running, it is still talking to your etcd. So you'll have to stop the kubelet onto the container. Okay, etcd running container. So now you have stopped the kubelet. Killed the process. So this is where your etcd will be residing unless you change it. Okay.
Okay.
So now we are restoring the snapshot DB. So we are not copying from the host file, which is already there. We are making use of it. So why I wanted you to take a backup to the host, just to tell you that we should not keep this snapshot DB inside the container, right? So that's why I just told you to take the copy in your host. Otherwise, it's fine. Like, yeah.
Lavanya, I'm so sorry. Can you please repeat once why we killed the kubelet and
yes. So we are going to restore on the same cluster, right? So what will be running on that node? Kubelet will be running. Okay. So what kubelet will do, it will constantly communicate with etcd, right? To update the states. So we have to stop it. Otherwise, what will happen? It will keep on talking to your etcd server, but we'll have to restore it, right? We'll have to restore it. So we'll have to stop all the connection. So similar to how you restore the database, you will stop the connections, right? For example, databases restore, you will stop the active connections, because during the restore, you don't want any of the connection to be there, right? So we are stopping the connection, and then we are also additionally stopping the process, kubelet process. Okay, so that ensuring that kubelet is not running. Yeah.
Okay. So here we are just stopping the kubelet. We are not deleting or we are not completely removing the kubelet.
We are not deleting the kubelet. We are just stopping that kubelet service. That's it. We're not doing
and we are reconfiguring with our snapshot. Am I correct?
Yes.
Got it. Thank you.
Did it work?
No, it says it's already existing.
Okay. Now remove that folder and check ls varlib is yeah rm dar, yeah. So go back to one more level and then delete the etcd or move the etcd. So mv etcd temp, can move it to somewhere temp and all. Yeah. So now you list. You don't have it, right? So now you try to run the restore. So I will append this in the document. Yeah. So now what happened? So it has taken that snapshot.db and then it has restored it. So last message you see. So first is restoring snapshot. Second one is adding member in the message you will see. So and third is restored snapshot. So these 3 lines it just mentioned, right? So it just yeah, it just restored it. So basically, why we are using it, moving this varlib etcd? So already an etcd is there. That's what it is complaining. So that's why we have to restore in a clean place. So it should not have kubelet running, and then it should not have already running that etcd db, right? So we are just disturbing that and moving it to some other place to ensure that we can restore this snapshot. So that's what we did now. So in production, we don't remove this varlib etcd. Instead, we create in a new folder. So configure etcd new and then use that as a data directory. Got it? So we don't do that movement and all. Just for the demo purpose, we are moving it. Otherwise, we do it in a different directory. Instead of varlib etcd, we do it in varlib etcd new or something like that. So, but the underlying concept remains the same. So now it restored the database. So now you do one thing, go back to the document. So restart the kubelet. So we have stopped the kubelet, right? So we are starting the kubelet.
I just want to check the status once.
Stopped. Yeah. So do one thing, do restart of the entire Docker. Go back to the document. So now it has everything running, right? Just restart the control plane. Yeah. Yeah, that's it. Just restart the control plane. This is fine. You don't need to run any of it.
Okay.
So Docker restart, go back to the previous Docker restart etcd control plane.
You have to come outside of the container.
Yeah.
You are inside the container.
Actually, it is not the. I think you copied it.
Restart.
So go back to the document again. No, this is fine. This is right. Go back to the previous line number 182. Yeah, run this. It's fine. Just you run the kubectl get namespace. Let's see what it has done. Did it restart? Maybe what you do, you can just run the kubectl. Kubectl will get nodes, or yeah, because there's a restart command is not working. Maybe do another restart or something, or do the restart from Docker UI also. etcd last one, yes. Yeah, pause and start. That's fine. It's okay. What you do, go back to the document again. So it should work. It's fine. So now we can restore it onto a new cluster as well. So yeah, this issue we might get often when we are using the kind cluster. Just restore it onto a new cluster. So this will also work. So no, you create a new cluster now from the start.
But why can't we try stop and start here?
It should work. It should restart it. But the Docker container is not starting for some reason.
Oh, okay, got it.
That's it. Otherwise, it should work.
Okay.
You can use the same command which I mentioned, just to go back to the document, because it would be easy for you to just come down. Where you stopped it, right? No. Yeah. Restore onto a new cluster. This section you follow. Yes.
Okay.
So now you got the importance of taking the snapshot.db to your host, right? Otherwise, you would have lost the snapshot.db if it's there in that same machine, which is gone now.
Yeah.
So you created the cluster and now you are stopping that control plane. Copying that to the Docker container. Okay.
Okay. Is this inside the Docker or?
Inside the Docker. Yeah, I think I missed it maybe. I'll fix that. So I pushed the changes. If you want, you can refresh and take it.
Okay.
No, it's inside the Docker, not the kubectl. So just go back to the document, refresh it. Yeah, Docker exec it. Yeah, from here you start. Yes. So now you run the, remove the etcd and restore it.
Removing this cluster's etcd with and replacing it with
Our own cluster. Yes, we have taken backup. So it should restore all the namespace that we have created in the previous cluster. So you can restore it onto the same cluster, or you can create a brand new cluster and then restore it there.
Okay.
So we wanted to try both of them, but yeah. Okay, before restarting, you do one thing, just give kubectl get namespace, run it in other terminal. It's not starting. Okay, restart the Docker now.
Is it service?
Yeah, it should be there. Docker restart new. Yeah. Not inside the, do it from your host machine. It's Docker restart.
Okay, okay.
Maybe wait for some time. Let's see. Did anyone else try it in parallel? They can show if that works. Yeah, maybe it should work.
Yeah.
So meantime, you do one thing, you switch the context to the old cluster. You know what I mean, right? So add another cluster, config get context. Yeah. So you are now in new cluster. Yeah, move back to kind etcd, right? Config, use context. Contexts. Oh yeah, that should work. Yeah, okay. Get pods, whatever. Yeah. Still not up, is it?
Yeah, still not up.
Okay.
I think she can do Docker restart. Maybe.
She did it already. You can try again one more time. Let's see. Docker restart that etcd. So Docker restart, I'll tell you the command. Docker space restart. Etcd hyphen control hyphen plane. Okay. Wait for some more time. So let me do that in parallel. Just give me a few minutes. Okay. Let's see what's happening. Lot of kind clusters, is it?
Yeah, too many climbing clusters.
Okay. Maybe what you can do, you can delete if you're not using some of them.
Okay.
Okay, delete those containers. Try the live. If someone else tried it, just share your machine. Hello?
Yeah.
So I did a restore on my machine using the same etcd. So maybe it should work if you retry it. So the issue is with the Docker container, it's not getting started for some reason on your machine, Swarna. So what I did, I created the same kind cluster, and then I created a few namespaces, test2, test3, and then I created a deployment. Then I installed etcd-ctl and taken a snapshot up to this point. So where I should have test2 and test3. So that is my snapshot point. So up to here only I have the data in my snapshot.db. So after that I created test4 and test5 and then did some changes and then created few deployment in test4 as well. But this is after the snapshot.db creation. So now I just did a restore onto the same etcd. So then what it did, it reverted my namespaces and also this will not be there because it just used the snapshot.db and then restored it. So if I go ahead and check my kubectl get namespace, I will not have test4 and test5. I'll only have until test2 and test3. So up to here only I created the restore point. Okay. So then, so what I wanted to say is with this snapshot restore, backup and restore method, there will be chances that there will be data loss. So your cluster state will be reverted based on your snapshot schedule time. So for example, if you are reverting to 1 day of a previous restore date, then all the changes that you did after yesterday, that will be lost. So that is one of the impacts that you should keep in mind. So accordingly, you will have to take a backup. So maybe if it is a high critical environment, one hour once or something like that, you can do. Okay. So you can restore onto the same machine, or you can spin up a brand new machine for etcd and bring that machine into your cluster. So if it is three highly available etcd machines, then the same has to be repeatedly done on all those machines. You have to stop kubelet on all 3 machines and reconfigure kubelet using this restore mechanism on all 3 machines and join that machine as a master. Okay, got it. Any queries? Yeah. But I want every one of you to try the lab and experience what you are doing.
Yeah, even I'm getting the same error actually.
Okay. Maybe you could, if you could share, let's see once.
Oh, now it's okay.
Maybe it all depends on the Docker.
It is working. Yeah.
So just explore the namespace, whether it has 4 and 5. It should not have. Yeah, I see that there is no namespaces. Yeah, that's fine. Yeah, so you got the concept, right? I don't want to not experience with what we are doing. I want everyone to try the lab. Yep. So I did give a task today just to see the Cilium network policy. So you will face similar issues like kind cluster getting dropped. So just do a retry of 1 or 2 times. You should be able to see the Cilium Hubble UI and see the traffic flow. So just try one L3 level traffic routing, L4 and L7. Create a network policy to allow and block and test some deployment. Do a curl and then try how it is behaving, so that you will get a full experience of Cilium. So I think with that, we will stop the Cilium class from here. So if you have any question, let's do a recap next week before starting the next class. Okay. but we are mostly done with the Cilium. The Cilium itself has a certification separately. If someone of you are interested, or if you want to plan to use Cilium, just go and enroll for that Cilium certification and do it. But if you need any additional details like how to proceed for the certification, let me know. I also have a few offers. Since I am the Golden Cube astronaut, I have completed Cilium certification and I know how to guide you if you are interested. Okay. Yep. I think, thank you, team. That's it for today. See you in the next class.
Thanks, man.
Bye.
Thanks,
Thank
Lavanya.
you.